Okay. Remember, lunch trash goes in the lunch bag, please, if you have any more trash. You're welcome to finish up while we start in. So we're actually, oops, I got a couple of waiting. Okay, guys, we are on our old note packet. Right at the end, there are a couple questions I want to get covered, and then we'll start in on our new notes. Okay? So the old one, very back where the projectile motion problem ended, you'll see there's a couple problems down here at the bottom. We need our books. And we're going to just do a couple of quick problems on page 81 in our book. Couple of quick problems, page 81 in our book. Actually, it's 82, sorry. So we got our books up. I know you guys on the screen, your books on your iPad, you need to go there, that's okay. Okay, listen one more time. On the old notes packet, the very back page of the old notes packet, down at the bottom, there's a couple of things to fill in. Okay? If you don't have it, just write these down somewhere. All right, so page 82, we're looking at problem number 12. This is not really what the heart of this chapter is about, but it is a good thing to look at because, especially this time in the world right now, you're getting bombarded with all kinds of information, and you have to be able to interpret that information. So they give you a chart here. It has employment statistics. I'm on page 82 of my textbook. And you are asked in problem number 12, what has been the trend in males joining the workforce since 1954? So look at the male column, and if you had to describe that in words, what would it be? What has been the trend? Okay. Do you have our book out?
What page did you say, 82?
82. We're doing problem number 12, but it refers to,
Oh, wait a minute.
what's the matter? Never mind, you gotta figure it out. Okay, so is there anybody in here looking at the chart on page 82? The table of values?
Yeah, I think I'm looking at the, yeah.
Oh, it's different number on the book.
Yeah, that's what I think, I'm thinking of the table.
Oh, what, it doesn't look the same on the
Well,
computer?
It has page number, and then at the bottom it has the slide number and they're different.
Okay, well, this is page number. So find page number, page 82, and let me see if it looks like my 82.
No, 2003. I read that wrong.
Yes, if you look at the page number.
It's on slide number 107.
Okay, so don't look at the slide number, look at the page number. Okay, so now are we all looking at the table? Okay, what would be your conclusion if you were asked how the male employment is trending since 1954? Okay, everybody in here speaks my language, right? We know what trending means, what direction does it seem to be going. So let's look at the male employment, the male column. Let's look at the numbers. It starts at 54 and ends at 04. What is happening to the male numbers as you go down that chart? It's what? Decreasing. So how is the male employment trending? It is decreasing. Now, can anybody think why that might be? 1954, that was before I was even born. That was a long time ago, 1954, till present time. Why would it be that the male employment numbers might be decreasing? This isn't a math question, this is a common sense question. What happened in our society that would make male employment numbers go down? Women started working more. And so women worked more, so men had to work less. When I grew up, the dads worked and the moms stayed home. When I was a child, back in the 60s, that's the way it was. But then over time, really during my lifetime, women started working. Women had more opportunities, and so more dads, more men, got to stay home and be the caregivers, or instead of having 2 jobs, they only had 1 job because their wife was working. So of course those numbers came down. What do you think happened to the women numbers? We didn't look at that question, but look at the chart. What are the women numbers doing? Of course, they're going up. Right, they're going up. Now, question 12B. In what 5-year interval did the percentage of men change the most? So the data is in 5-year intervals. So you're just looking at the numbers, and where does it seem that it changed the most? I'm looking at the male column, the men column. Where does it look like?
Up or down, right? For men?
The men.
Yeah, it doesn't matter if it goes up or down.
Yeah, it doesn't matter if it goes up or down. Where did it change the most?
1994, 79 to 1999.
Well, it'd be 79 to 84.
Oh, yeah.
We're going in a 5-year interval. So I think you're right. I think 79 to 84 is slightly bigger than 69 to 74, isn't it?
Oh, wait, 69 to 74.
I think that
I
one,
think that one's bigger.
I think that's 3.2, and 79 to 84 is actually 3.3.
Oh, okay.
So they're very, very close, but yeah. All right, one more on that page, number 20. Again, this isn't a chapter 2 type problem. This is a problem that is common sense that you may actually have to figure out sometime. You're going to go buy a birthday cake for somebody, and you have 2 choices. You can get a 9 by 13 cake, so you know that's a rectangular cake, and it's a single layer. You know, you've all seen that before, like a sheet cake, a small sheet cake. Or you can get a 8-inch diameter round cake, and it is 2 layers. So you all seen that too, the round cake, layer cake, you know, you've all seen it. So you go into the store, and they're the same price. And you don't really have a preference. So you're gonna make your decision based on what? If they cost the same, on the volume, how much cake is actually there, right? So how do we find the volume of this rectangular cake, a cake that kind of shaped like the book here? Exactly. It's a rectangle, what we call a rectangular solid. It's length times width times height. Now, the length and width, we'll just say 9 by 13. And they didn't really tell us the height, but they told us it was a single layer. So let's just say 1 inch. It could be 2 inches, it could be 3 inches, it could be whatever you want. All we really care about is this one's gonna be twice that, because it's a double layer. All right, so the volume there is, let me see if I can multiply that in my head, 117 cubic inches. So if you buy the rectangular cake, you're gonna get that much for your money, okay? Now, go over there. Now we're looking at the layer cake, the round layer cake. And that's an 8-inch diameter. Okay? How do we find its volume? It is not a rectangle, so don't say length times width times height. Okay, pi r squared would be the area of it. What's the, a circle, pi r squared, that's the area of it. What shape, think about that layer cake. It isn't a circle, I mean the top of it's a circle.
Cylinder?
It's a cylinder. This is a cylinder. So we need to know what the volume of a cylinder is. What is the volume of a cylinder? You may know that formula, Jake? Are you looking it up?
Yeah, pi r squared times height.
Yes, pi r squared h. So, Princess, it was pi r squared, the area, then the height thrown in there. So, pi, what's my radius?
Oh,
4. So that's going to be 16, 4 squared. And my height is 2. Now again, they didn't tell me that, but they told me it's double this one. So when I let this one be 1, this one would be 2. If I let this one be 2, this one would have to be 4, right? All right, so now I'll type that in on my calculator. I don't know where my calculator got to. Where did my calculator go?
Yeah, I see what
No, I didn't, I mean, yes, that is mine. But, I just had mine. Well, I'll have to locate it, but let's see if we can type in what's pi r squared h. You put the lid on backwards, Jake. Pi times 16 times 2. I got 100.53 cubic inches. Is that right? So if you are really interested in, here it is, right here. If you're really interested in getting the most cake for your money, which one are you going to buy? The rectangular one. Sure, that's the one you're going to buy. Okay, guys. Oh. We are done for the day, guys. See you later. See you tomorrow.
Thank you.
All right, let me spread.